So you can tell already from the title of the talk that I'm an AI skeptic, and AI is going to turn out to be useful for certain things, but it's basically, as we all know, hugely hyped. And so, I've kind of practiced over the years technology forecasting. And some of you may be aware that sometimes that succeeds, sometimes it fails. But some of you might be aware that in the late 90s, or even mid-90s, as HDTV standards were being developed, I've figured out that computing was going to be really important to video. And when the proposal was issued by the NHK, and then largely assisted by Sony, to have HDTV that was 1920 by 1035, leading to little image elements or pixels that were 4% more closely spaced horizontally than they were vertically, I thought, that's a big mistake. And there was this absolutely memorable dinner I had. I wonder if I can, we're being recorded, right?
Yes.
Can we turn off the recording? No, as you wish, but I can be more candid. Okay, let's say two people, senior with Sony, having dinner at a SMPTE conference in Chicago, and I remember it extremely clearly. One of them said, and he's a friend of mine and a really good guy, but he was sitting at the table and he said, Charles, that square pixels thing is a really good idea, but it's too bad that train has already left the station. And basically we came this close to having HDTV and all of video and all of digital cinema having non-square pixels. And you can just imagine what a catastrophe that would have been. So then that was maybe my biggest success in technology forecasting. And there were a few failures, but that was a big success. And I've been practicing the art of technology forecasting, ever since. So then my forecast for AI is be very cautious. And I'll tell you why as we go. So then you might think, well, what's this guy, a color scientist? Okay, he, in the ancient era, did a lot of HDTV and digital video stuff, but what's this color scientist doing up here talking about AI? And I think why me is I'm not an AI expert at all, but I know a lot of math. And I didn't learn it at university. I failed out of calculus with a 23% grade, but somehow they gave me a bachelor's degree. And I then learned math after the fact. And then later, I thought, okay, I can't actually do math. I'm going back to school. So I went back to school and got a PhD. Later in life, which I don't recommend to anyone, but that's what I did. And so why me? Well, it turns out that I fluked in, as many of us sort of progress through our professional careers, I fluked in to having 3 or 4 extremely fortuitous things happen when I was a youngster. So one is, my first computer language is called APL. So hands up if you know APL. Oh, this is really great. We've got 3 people who know what that is. It's an extremely obscure computer language devised in the late 60s and very early 70s which was based upon vectors, matrices, and arrays, and an extremely well thought out mathematical basis. And so I came to write computer programs like that, and that helps in big math. The second thing, getting lucky, was my professor, in fact, the guy who introduced me to APL, had just finished at IBM research in Yorkton Heights, and he had programmed into APL what he called matrix divide, which is really a very carefully formulated version of matrix inverse. And he was kind of my mentor, and I'd learned linear algebra really early on. That wasn't on the course in mathematics at Queen's at the time. So I did actually end up leaving Queen's knowing linear algebra, but not having that taught to me in any of my undergrad courses. And linear algebra is the key to understanding math in AI. And there's an interesting article I read a couple of days ago in the Communications of ACM, the big communications journal. What did she call it? She said that it's the hardware. AI succeeded because of the hardware lottery, and the hardware lottery she was referring to is GPUs, so graphic processing unit, not the CPU. Like the CPU has been in development for half a century, but through a fluke, video games required transformations of objects that the CPUs of the day 25, 30, 35 years ago couldn't do well, and that led to a kind of separate branch of computing, leading to the graphic processing unit, and it does linear algebra, basically. It's a linear algebra machine. So if you really want to understand AI and machine learning, you'll need to read up on that. And then, I ended up doing signal processing, DSP, which also has a lot to do with vector architectures. And that's really what enables AI today. So, I just got lucky. So where we end up today is this long history of what I call machine learning, which is that really it's just linear algebra. But the hype is not associated with that. The hype is associated with artificial intelligence. And one of the conclusions that I've come to that I can share with you today is I think machine learning is more important to media and entertainment than AI. And then, if I can kind of jump ahead to a few of my conclusions, it'll need to be on your own data because the big tech companies, they're not in it to help you. They're in it to help them, and they are gigantic. And we all know the ones. Well, I'm gonna maybe I'll list them because there's one that might be surprising to you. So Google, rooted in search, and by the way, Google was founded based upon two PhD students at Stanford who figured out linear algebra, and in particular eigenvectors and eigenvalues. They wrote a paper. They titled their paper PageRank, and they basically had a large matrix where each element in each row, it's a square matrix, each row and each column is one page on the web. So it's but this was 1994, 95, maybe a little later, could be 96. And they computed an eigenvector of that matrix. And it was like a really, really difficult thing to do at the time. And so then linear algebra is even at the heart of Google, which we've all been using for 30 years. So then to really grok, well, I'm sorry to use that word, machine learning and AI, you need linear algebra. So then, I mean, not all of you want to do that. In fact, probably most of you don't want to do that. But if you're going to try to capitalize on machine learning, and I'm trying to steer you away from AI, you can use that name for marketing if you have to, but machine learning is really, to my mind, the most useful and central technique. Then you have to have staff who understand linear algebra and programming. And to my mind, it's a question of kind of invest or don't. You know, decide one way or the other. Because the big guys, they don't have your interests at heart. In fact, their interest, and this is a key point, is training their models. So they've already scoured the entire web. Google has been digitizing books, and you may have seen the pictures of this, the hydraulic slicer to cut the spine off, and then an automatic page feeder, and then OCR. They've digitized, I don't know, my wild guess would be 1 million books, something like that. And they've trained their AI on that. And so AI that we are using today, that's its training set in the large cases. You're never going to be able to do that. So, you know, you're not going to be able to make big models. And I think Renard has already said, you might think about small models. And that's kind of aligning with my idea of machine learning. But the big companies have basically run out of training data. And you think, run out of training data? How can they run out of training data? They've got the entire web and 1 million books, or I don't know what Facebook, Meta, and Apple and Microsoft, they didn't carve apart books and digitize them. I'm not sure how they access the range of information that Google has got access to. But now, all of these companies want more training data. And they want to get it from you. And that's why you've seen in the last 2 or 3 months these amazing, huge, unbelievable announcements. Like Adobe, literally 2 weeks ago, pops up a dialogue when you launch Photoshop that says basically, by the way, we own your data. And they don't say that exactly in those words, but that's what the legal agreement says if you read the agreement. And that dialog box has got one button. It literally has one button. It says accept. And your choice is either you accept or you quit the app. And like Photoshop, okay, that's one thing, but it also applies to me for InDesign. And I have a huge inventory of documents, which I call my assets, in InDesign. And if InDesign stops working, that's a big problem for me. And it's led to a big backlash. Well, first of all, among the creative community. And just, general users, because we don't want Adobe owning our data. But more generally, you get the drift. They want to train from your data. And the trouble with all of these organizations training from your data, let me give another few examples. Slack. Hands up if you use Slack. Did you press the button that says, okay, you can train on my data? Because Slack has now got a corporate policy. I don't know the extent to which you can opt out of it. I mean, Adobe, you can't opt out at all. But Slack, you run the risk using Slack now that they're training on your data. And the odd thing about large language models, if that data finds its way into a large language model, that data will never surface to a kind of general query. But if you make a really, really specific query, that data can surface in the answer. And that is a vulnerability of your data. And this is a huge problem for lawyers. Well, okay, we saw the news already about the lawyers who didn't know how the large language models worked, so they didn't realize that they, quotes, hallucinate, which I really don't like that word, but AI models, large language models of the current variety, so based on what's called transformers, and it has to do with kind of very long sequences of text and the learning patterns of words. The whole basis of ChatGPT, to pick one large language model, is basically picking the next word. It basically goes one word at a time in generating words, and it picks the next word based on an extremely complicated probability distribution from all the training data. It has no understanding or knowledge and never will have. So this, quotes, hallucination idea, which I prefer to call it, I mean, I don't like it because it's anthropomorphic. You know, you don't want to describe computers as being anthropomorphic because they hate that. But they generate believable text, but it's just a probability distribution on 100 million words or 100 million weights. So I don't call it hallucination. I like to call it dreaming. And you know, that word came to me because I'm thinking about images generated by DALL-E or by Stable Diffusion, which have a very odd, unreal or dreamy quality about them. Like they all do. They don't quite look real. And you know, artists think, yeah, like it's just like a bad painting. It's a painting with no soul. Or as a friend of mine once said, there's no blood in it. Like it's got that odd quality to it. And it can't be otherwise because they can't reason, think, or understand. And you know, at the moment, the image generation models are just running in 2D. They don't understand geometry or shadows or placement of objects. And again, never will. Okay, so then back to large language models. So then one thing that you will never, ever, ever get out of a large language model is the answer, I don't know. It's by construction not there. But that's, to my mind as a human, that's a highly valuable piece of information. And you know, I learned that in my early consulting days. That, I mean, there's a classic line of, well, I don't know, but I can find out for you. But no, the most important part is I don't know. And so the fact that that's by construction impossible, that's a pretty big problem with AI in general. Now, if I back up to machine learning, the situation is way better because there the probabilities are in essence reported to you. And so you as a system designer of a machine learning system can declare that this answer is uncertain. And if your name is 407 ETR and you're recognizing license plates, you want to know the certainty level. Large language models just don't give you that. Okay, I've gone way off script here. So let's see. Signal processing transforms, page rank, eigenvector. Okay, so then, if you really want to get a grasp, at your organization, really want to get a grasp on it, one thing you do is hire service, contract, subscribe a service, but that makes you vulnerable to their business model and also then potentially compromises your data. And I argue that's not a good idea, and having a smaller scope and doing a more machine learning oriented solution I think is way better. So then another problem with large language models in particular is, I've heard a few people this morning speak of kind of, I forget the words they used, carefully constructing your data sets. You never get to do that in a large with a capital L model, because the training data is just way too big. You can't manually do anything. So you're vulnerable to your model building in, and we've already heard about bias, but it's not even just bias. I would use a much stronger term like misinformation or disinformation. And you've probably seen the examples that Google in particular has turned up about who was the first Muslim or has there ever been a Muslim president of the United States? And AI Overview very cheerfully reports, oh yeah, there has been, it's Barack Obama. Well, we all know he's not Muslim, but there is so much information on the web which, and forgive me for going way out there, but which I have concluded is a consequence of large state actors that have an incentive to disrupt functioning democracies. And so then the Russia example is the so-called, quotes, Internet Research Bureau, 30 full-time, really hotshot programming types who write code they write bot code. It's making statements that they know are false, but are spread widely on what I consider to be dysfunctional social media systems, and in particular X/Twitter. And that, I won't spend much time on this, but it's another problem that the large companies that are highly active, investing billions of dollars in AI, have got an overwhelming toxic tech bro masculinity that shows up all the time in public facing places. It's one thing to go to your board and declare what you are or are not doing. In the case of OpenAI, you might have seen the news that they fired the security team. That was, 6 or 8 weeks ago. You might have heard that Sam Altman, the CEO, was deposed by the board and then reinstated 3 days later. because Microsoft has invested billions of dollars in OpenAI, and they wanted him back. You know, toxic tech bro culture, to my mind, the pinnacle is Elon Musk, and so he's floating out a series of tweets literally yesterday about how Apple is clueless at AI, and that's why they are incorporating technology from OpenAI. And you know, I'm gonna, if that ever rolls out, I'm gonna enforce a rule in my employees that nobody can use an iPhone. Like, hands up if you saw that story. Like, a lot of you saw that story, right? So then this is just toxic tech pro masculinity invading the space, but at the level of billions of dollars. And it's a big, big, big problem, and it's not going to go away anytime soon. So, sorry, I got a little bit diverged on that. So then, oh, and you've also got Geoffrey Hinton, one of the three so-called godfathers of AI. Two of them are Canadian, by the way, but we're not good in Canada at supporting our pioneers. Geoffrey Hinton invented backpropagation, which is an absolute key element of advanced machine learning and all that follows. He quit Google 2 years ago because he thought that they weren't paying attention to how AI is developing and making it safe and reliable. He along with his two colleagues, Yoshua Bengio and who's the other one? They won the Turing Prize, which is, you know, it's advertised as the computing equivalent of the Nobel Prize. Hugely influential workers. Jan LeCun, that's number 3, works for Facebook / Meta. And he's publicly, he's a very interesting and brilliant guy. He's publicly said that large language models are inherently stupid, you know, which I agree with. He said that current large language models do not even have the intelligence of a house cat. And he says this very publicly, so he's worth paying attention to. And you know, he says why. Like, they don't have any spatial reasoning, they don't have any causality notion, they're just not smart. However, I mean, the good news is, and part of my take on this is tempered by a really close friend of mine who uses large language models all the time. And by all the time, I mean like once every 5 minutes. He uses them because they've read everything. So then, as long as you've got human judgment at the back end that's got the right context and the right background knowledge, like you know that Barack Obama is not a Muslim, then you can use it to fetch up information that would be extremely difficult to find otherwise. And you know, I did a PhD. It took me 13 years. It's teaches you how to go and find information. But whenever I look up information about, okay, here's one. The quartz envelope of a small xenon arc lamp. Is that crystalline or not? Anybody know? Pardon me? Like, I want to know if it's crystal glass, because it's quartz, and I don't know. So then, like, if you come to that question using a large language model, it has read the things that you would need to read to know that. Now, how successful you can be at filtering that out, that's kind of another question. So then these large language models are useful in certain limited contexts, but you better have humans paying attention to what they're telling you. Machine learning, not so much, because it's got a more solid basis on probability and it reports the likelihood that the solution is correct, which large language models obviously don't do. Okay, another topic. It's really interesting from a technology point of view that there's huge amounts of open source code for machine learning and AI, like huge amounts. And although at first glance you think it must be horrendously complicated, it is possible for a small organization to get a handle on it. So it's what I call do-it-yourself AI. So for example, there is a large language model written in C that's 2,000 lines of C. That's manageable. Like to those, so hands up if you can code C, if you absolutely have to, okay? Python. Okay, Python is actually more interesting, but C is higher performance. Any MATLAB coders? We got one, two. Okay, so then MATLAB is good at this as well. So then my argument earlier about, you know, if you're going to be serious, you have to decide whether to be serious about this or not. And if you are serious about it, you have to have expertise in-house, I think. And so I don't know how big that team is. It's probably more than one person. It could be 2 or 3, I think, would probably be the critical mass. But it's totally feasible. And okay, that's the do-it-yourself idea. Okay, there's been a string of papers recently about can large language models, and in particular the so-called transformer, it's the T in GPT. It's generative pre-trained transformer, which is a very specific kind of algorithmic approach to machine learning. There's been a string of papers. Can LLMs do arithmetic? And I'm thinking, are you kidding me? Like, from one point of view, no, they can't, because they're just looking at probability distributions of like millions of words. So they don't have anything built in that says 2 + 3 = 5. And so then you can present a large language model with a problem that involves addition, and it can be really simple, you know, 1 + 2. And the only way that it can come up with an answer is if you get a good match on some of the training data that's buried and comes from who knows where. So from my point of view, and I think, you know, I've read papers from Jan LeCun that's kind of agreed with this, that LLMs are never going to be intelligent. They're always going to be stupid by construction. And so, you know, let's keep researching. But that research is going to involve some form of embedding knowledge, not just probability distributions on training sets. And there's a really, if you're going to read one book, and it's 120 pages, it's totally approachable. It's titled, How Does ChatGPT Work? It's by Stephen Wolfram, who is genius level mathematician, but he's, some computer scientists, like Alan Kay, if you know who that is, consider him to have a large ego. So you have to get over that. But once you get over that, it's a totally readable introduction that's not heavily focused on math. You need to know a little bit of math, but it's super good. I just highly recommend it. And so then that'll give you a notion of how ChatGPT works, which I think is valuable. But Wolfram is the inventor, proprietor, developer of Mathematica, which is really the kind of small-ish but highly sophisticated competitor to MATLAB. So hands up anybody who's programmed Mathematica. Nobody? So this is my favorite computer language because it's a computer language that does math. And it's very well aligned to APL, which was my historical roots. So it comes naturally to a person who thinks about programming not just one little thing at a time, but like vectors and matrices and three-dimensional arrays. And the interesting thing about Mathematica is that the data is intrinsically structured, but by whatever way you want. So where MATLAB says a vector is just a string of numbers, which might be the coefficients of a polynomial, Mathematica just lets you write the polynomial. So you have to know a little bit of math, but the structure suits the problem. So then Wolfram took all that and made Wolfram Alpha. So hands up if you know what that is. Okay, this is super valuable and super good. So it's on the web, wolframalpha.com. And it's got a text field where you type in a question. But what's underneath it is not a kind of probabilistic, plausible sounding answers. What's underneath it is a very large set of curated and structured facts. So you can literally say to Wolfram Alpha, what is the gross takeoff weight of a Boeing 787? And that's part of the curated data, but made by a human. And the sources are available, and it tends to be extremely reliable. Siri from Apple was spawned by two things. One is voice recognition and natural language recognition from a Palo Alto company called, anybody know? Stanford Research Institute. Siri. That was half of Siri came from SRI. The other half is Wolfram Alpha. But they don't advertise it. Neither Apple nor Wolfram advertises that fact. But their factual information is coming from there. Okay. Okay, hands up if you recognize the names of the following companies. Magic Leap. Okay, was it 1 billion, 2 billion, 3 billion? 4 billion, thank you. Okay, Hyperloop Boring Company. This is just a ploy to keep buses off the streets. Theranos. Okay, she's in jail. 23andMe. Hand us your DNA and we will not secure it in our servers so that it will be hacked and available on the dark web. Not a good business model. Equifax. Hacked. 8 million records gone. Just the other day I was, we moved our 93-year-old auntie into a retirement home, thankfully. It's about time. So I went to the post office to file the change of address. How do you file the change of address? I went to the post office because to do it online, how do you do that? Well, you go to Equifax and you scan your passport and your driver's license. Because Canada Post they don't have the savvy to do it themselves. Like, am I going to give Equifax my passport and my driver's license? Okay, Juicero.
They have it already.
Well, okay, maybe they haven't already, but I'm resisting still. Juicero, hands up if you know it. Okay, this is a juice machine which was on subscription. It's now gone. HP ink cartridges. Okay, it's a disaster, right? So then the trouble with handing your essential requirements over to large companies is it's not highly trustworthy. Okay, that's really all I've got for you. But I would, if you really want to see the version that's got a lot of slides, I figure even just for this talk, that's like 1 day worth of slides. But I would also like to teach the math, and I figure the beginnings of that are a day. And if you want me to teach the math, just talk to your local SMPTE chapter section manager and put in a good word, and maybe I'll do that. Okay, there's a few minutes for questions. And, it should be clear. I'll take questions on anything.
What's the name of the book that you mentioned for Stephen?
Stephen Wolfram, so Wolfram.
Great, thank you.
How does ChatGPT, subtitle, how does it work? Yep.
And I'll get you to please stand up when you ask a question.
Everybody do their stretches. How's that sound? Anyway, Charles, first of all, thank you for Square Pixels. He needs a round of applause for this. Certainly, I was in the loop on that. We won't discuss the people in Chicago.
Oh, I'll tell you after who they were.
Afterwards, but anyway, no, that was great that you did that. Otherwise, we'd be in real problems,
Yeah.
particularly.
Yeah.
Not just in our industry, gaming and everywhere else. It would have been a nightmare as far as that goes. I like your comment about without a soul, painting without a soul.
Mm-hmm.
Certainly, I've seen that within AI objects. But the real question comes up to, as you said, ML can say I don't know, but AI can't. So is that like a never fixed thing?
Yeah, it is on transformer-based models, which are the root of the big LLMs. So I mean, for sure ChatGPT, I'm pretty sure Llama, Llama is large language, meta AI, Llama. And I'm pretty sure that's got transformers at the root. So then there's this very sophisticated algorithm to do this probability, building and matching and generation. And it just can't. Well, okay, let me put it even more clearly than before. My view, and this is, I think, key to media and entertainment, by construction, AI cannot be creative. I can just say it flat out, because it's just based upon probabilities. So ordinary people in the street might think it's creative in the same sense that, well, I kind of hate to use the word bad art, but if there's a painting that you just doesn't resonate at all, like you hope that person is going to get better. AI is never going to get better. It by construction cannot be creative. So then we need to work in media and entertainment to figure out, well, then where is the creativity? I mean, there's this press release from the CEO of Sony Pictures last week who says, we're gonna do massive amounts of movies using AI. And I think, well, they're gonna not look very good because they're just not gonna have that thing that the creative people know the artists.
Spinning Mad Max 12, 13, 14.
Oh, well, then there is that. I mean, I had, 30 years ago when I was teaching MPEG, I used a slide which was, do you call it in the business the log line? It's the 2-sentence description of an episode of a TV show. Am I using the term correctly? And so then more or less my opening slide teaching MPEG was, if you really, 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 really want high compression of a 26-minute image sequence, you can express it in 170 bytes. It's the log line. But there's creativity way beyond that you have to decide, how much to represent. And just the trouble with the transformer-based models, they will just never do that, ever. And Jan LeCun, he says so very directly. Okay, is there?
And we do have a bit more time. That was said.
Oh, yeah,
So
okay.
we're okay for
So,
more questions. If
yeah,
there are.
more questions, please.
Please stand up. If you can just.
Thank you. Just a curiosity, you're looking at machine learning technology. You're looking at quote the AI technology, right? Do you ever see where there's a combination of hybrid models, so that a hybrid model can detect the fact this model's dreaming, or it can actually say, no, this model doesn't know the answer, right?
Yeah, there's certainly people working on that. And I don't understand it yet. There's a... I'm sorry? Oh, yeah, well, I'm game anytime. But no, there is a technology which I don't yet understand called retrieval augmented generation, RAG. I don't know if they picked that deliberately, which is sort of attempting to correct errors in generative models, like fix the mistakes, and then prevent the so-called hallucinations. I don't think there's long-term promise in that technique. I think the likely scenario, we've got a huge hype problem, and so, the reason that I mention the failures of these really large companies is they had hype as well, and they just didn't succeed. Now, I don't think OpenAI is going to close their doors anytime soon, but we, as a technology forecaster, I think, what's the 5-year, the 10-year scenario? And I think the scenario is that the really smart people keep working on the problems, but they're not stuck on LLMs. And so, and I'm thinking of kind of scenario where you combine Wolfram's symbolic knowledge idea into machine learning and AI, and have answers that are kind of correct by construction instead of synthesized on the fly.
It's almost like you're creating a model or a process that's simulating the human management of responses, right?
Yeah, well, the human brain. All of this, the entire field of AI started, well, there was a very specific conference, and if you're interested, to me, it's just absolutely fascinating. There was a conference at Dartmouth University in 1956, and if you read the attendance list of that conference, it's like unbelievable. I won't name the names. Maybe I'll name one. Claude Shannon. Shannon Nyquist. He's basically the inventor of information theory. So he was there. John McCarthy is a very, very influential computer scientist. He invented the language called Lisp. which is really the basis of Stephen Wolfram's Mathematica. So then I'm looking for the fundamental people of that caliber, and I think the 3 Turing Award nominees, awardees, I guess, they call them laureate? That would be the Nobel word, I think. You know, look to them, see what they're saying, see what they're doing. I mean, yeah, the interesting thing about Jan LeCun is he's just out there stating this stuff very clearly and directly. And I mean, he's working on that sort of idea. He's not stuck on LLMs. One more?
Charles, here's a softball question. Did Elon Musk buy Twitter for the data set?
No,
Oh, really?
no.
Okay. You don't have to expand if you don't want to.
No, well, I can a little bit. I mean, I abandoned Twitter. So I went from 3,000 followers to a couple of hundred. But I'll take that hit because I can't engage in the encouragement of toxic masculinity, you know, tech bro culture. No, I think he wanted to control the flow of information. Okay, I have a minor theory about this. Does anybody know, does anybody know Russian? Nobody, okay. Oh, you do? Okay, what is the meaning of the Russian word pravda? Okay. Yes. Yeah, this is I don't speak any Russian, but this is what I've understood. So pravda in Russian means truth. And like, I think it would be an unfair question to ask how many of you own a copy of my book. But, well, there's a few hands anyway. But I think there's an entry in the glossary under truth, which says basically, never trust, it's Poynton's 4th law, never trust an organization that calls itself or titles its documents truth or fact. There's one other I can't remember. So Elon wanted to control the narrative. And it's clear from who he's canceling and who he's reinstating. And he does it personally, right? It's not even a team. He just, if he doesn't like something, he just says, delete it. Oh, and okay, and this is not a coincidence. Elon's first, well, not a coincidence that Donald Trump's platform is called Truth Social. Not a coincidence. And Elon, even before Trump's Truth Social, Elon was already thinking about large language models and deployment. And the first name for his large language model was Truth GPT. So, you know, he wants people like consumers, let's say consumers, to believe that this is objective and truthful, and it's just not. So I bailed out, and
All right, well, thank you very much,
cheers.
Charles.
Thank you.
Appreciate it. Yeah.